Hello and welcome to Free Scientist. This video is about Archimedes' principle of buoyancy or upthrust force.
If we threw any body in a jar containing a fluid, some bodies sink down in the fluid till it reaches the bottom of the jar. While other bodies float on the surface of the fluid. What is the scientific interpretation of this phenomena? Buoyancy or upthrust is an upward force exerted by a fluid that opposes the weight of a partially or fully immersed object. In a column of fluid, pressure increases with depth as a result of the weight of the overlying fluid. Thus the pressure at the bottom of a column of fluid is greater than at the top of the column. Similarly, the pressure at the bottom of an object submerged in a fluid is greater than at the top of the object. The pressure difference results in a net upward force on the object. The magnitude of the force is proportional to the pressure difference, and, as explained by Archimedes' principle, is equivalent to the weight of the fluid that would otherwise occupy the submerged volume of the object, i.e. the displaced fluid. For this reason, an object whose average density is greater than that of the fluid in which it is submerged tends to sink. If the object is less dense than the liquid, the force can keep the object afloat. This can occur only in a non-inertial reference frame, which either has a gravitational field or is accelerating due to a force other than gravity defining a downward direction. We can express this relation in the equation Fb equals rho Vg. While Fb is the buoyant or upthrust force. Rho is the density of the fluid. V is the volume of the body. G is the acceleration due to gravity. What is the density? The density of a substance is its mass per unit volume. The symbol most often used for density is rho, the lowercase Greek letter rho, although the Latin letter d can also be used. Mathematically, density is defined as mass divided by volume, which can be explained by this equation. Rho equals m over v. While rho is the density, m is the mass, v is the volume. This means that as the buoyant force of a fluid is directly proportional to its density, so a body that floats in a fluid may sink in a fluid of less density. For example, water has more density than ethanol, so as shown in the figure, two balls of the same mass and volume, the first floats in water and the second sinks in ethanol. The density of the same material is not always constant, as it is influenced by pressure and temperature. For example, in the shown table we can see that the density of water is changed by the change of its temperature. We also notice that its density under the freezing point 0 is less than its density in the liquid state, which means that ice has lower density than liquid water. For this reason we can see ice floating on surface of water. But what is the scientific interpretation of this phenomena? Most materials have more density in the solid state than the liquid state. But water is an exception because a water molecule contains one oxygen atom and two hydrogen atoms connected to the oxygen atom by a covalent bond, as shown in the figure. The slight positive charges on the hydrogen atoms in a water molecule attract the slight negative charges on the oxygen atoms of other water molecules. Each of the two hydrogen atoms makes hydrogen bond with other molecule. In liquid state there is enough temperature that makes kinetic energy that causes breaking of the hydrogen bonds between molecules, but when temperature decreases till water reaches the solid state there is no enough kinetic energy to break hydrogen bonds between molecules. So as hydrogen bonds make space between molecules, causing decrease of density, which makes ice float on liquid water.
Gas balloons rise up in air depending on the buoyant force of air as it is filled by gases of less density than air. High-altitude balloons are manned or unmanned balloons, usually filled with helium or hydrogen, or in some cases methane, that are released into the stratosphere. The most common type of high-altitude balloons are weather balloons. Other purposes include use as a platform for experiments in the upper atmosphere. Modern balloons generally contain electronic equipment such as radio transmitters, cameras, or satellite navigation systems, such as GPS receivers.
For a body that floats in a fluid, how to calculate the volume that is immersed in the fluid and the volume that floats above the surface of the fluid?
There are two forces acting on the body in two opposite directions, which is the body weight which is acting downward and the buoyant force of the fluid which is acting upward. The two forces are equal when the buoyant force of the replaced fluid is equal to the weight of the body. When the two forces are equal, the body is stable. The body density equals its mass over its volume. The body weight equals m times g, while m is the mass and g is the acceleration due to gravity, which is 9.8 meter per second squared. We can explain this by the following equation. W equals m times g equals rho b times vg. Rho b is the body density and v is the volume of the body. When the body weight is equal to the buoyant force of the replaced fluid, we can explain this by the following equation. Fb equals rho f times vi times g. Rho f is the density of the fluid, vi is the immersed volume of the body. And as Fb equals W, then rho f times vi times g equals rho b times v times g. By cancelling g from both sides of the equation. Then rho f times vi equals rho b times v, then vi equals rho b times v over rho f, and as rho b equals m over v, then vi equals m over rho f. In the shown figure, the buoyant force on the boat is equal to the weight of the water displaced by the boat, and if density of water is 1000 kilograms per cubic meter and the volume of the boat is 50 cubic meters and its mass is 20,000 kilograms. Then the immersed volume of the boat is 20,000 over 1000 equals 20 cubic meters. Then the floating volume of the boat is 50 minus 20 equals 30 cubic meters. The center of buoyancy of an object is the centroid of the displaced volume of fluid. Center of gravity is the point in a body where the gravitational force may be taken to act. While center of buoyancy is the center of the gravity of the volume of water which a body displaces. Stability becomes an important consideration when floating bodies such as a boat or ferry is designed. It is an obvious requirement that a floating body such as a boat does not topple when slightly disturbed. We say that a body is in stable equilibrium if it is able to return to its position when slightly disturbed. Failure to do so denotes unstable equilibrium. What equilibrium a body enjoys is decided by the couple formed by the weight of the body and the buoyancy force. Consider the immersed body. If the center of gravity of the body lies below the center of buoyancy, stable equilibrium prevails. An overturning couple leading to unstable equilibrium results if the center of gravity is above the center of buoyancy.
Thank you for watching.